Why in the world do we need airbags? We're going to figure that out this section. So some vocabulary review, preview. The kinetic energy is the energy of motion. The formula is K equals 1/2 mv squared. Work is the amount of energy added or taken away from a system. And a system is a group of one or more objects. Specifically, the amount of force applied to an object over a certain distance. Work equals force times displacement. Joule, like pool, is the unit for energy. What do you think? Hopefully by now you've taken time to consider this question. How does an airbag protect you during an accident? We know basically what an airbag is. We know that an airbag is for our safety, but how exactly does it protect us? In this investigate, we dropped and threw eggs to see how the stopping distance affects the force required to stop the egg. The goal of dropping the egg different heights was to get it to stop. And then when we threw the eggs at the sheet, we also wanted it to stop as well. Some important stuff from our physics talk. We have the formula, kinetic energy formula. K equals 1/2 mv squared. In this formula, K is kinetic energy, and the unit for kinetic energy is joules. It's also a kilogram times a meter squared per second squared, but I'm good with it if you just call it a joule. Mass is the m part, and that's measured in kilograms, and v is still velocity measured in meters per second. Don't forget about this little square up here. So that square means that velocity has a much bigger impact on how much kinetic energy you have. For example, our equation is K equals 1/2 mv squared. Let's say we have two objects. Both objects weigh 2 kilograms. So our mass is 2 kilograms. And the first object, V1, is 2 meters per second. V2, we're going to double that mass, or double that velocity, and that's going to be 4. And let's see what happens to our two kinetic energies. So the first one, half of the mass, if the mass is 2 kilograms, half of that is going to be 1 kilogram times V squared. V1 is 2, 2 squared is 2 times 2, so that's 4. So that means our kinetic energy equals 4 joules. For the second object, we have kinetic energy equals half of the mass again, which is 2 kilograms, so it's 1 times 4 squared is 16. So kinetic energy here is 4 times as great, 16 joules. Now let's look at it to see what happens if we double the mass for each object, and we're going to keep the velocity as 1. So now for the second one, the 1/2 mv squared. Both objects are now going to move with a velocity of 1 squared, which is just 1. And we'll still take half the mass. So let's say we're going to take, the m1 is going to be 10. We'll we'll use the same two numbers. m1 is going to be 2, so half of 2 is 1. So K equals, our first kinetic energy equals just 1 joule. Just in case you couldn't see it. I'll zoom in there for you. And then for the second one, if we double this mass from 2 to 4, so it's half of 4 times 1 squared, that's going to be 2 times 1 squared. So this becomes 2 joules. All right, so we use the same equation 4 different times. The first 2 times, we doubled the velocity. When we doubled the velocity, the kinetic energy went up 4 times as much because of that square. Then for the second one, we doubled the mass. And when we double the mass, the kinetic energy goes up by 2. So that means the velocity has this huge impact on how much kinetic energy you have.